With the 5 tablespoons of salt now evenly distributed through the water, I will now see what the new voltage reader is saying about the voltage that is able to be passed through this water. Looking to the voltage reader, there's another jump in the voltage from the previous, about 0.03 to 0.02 volt difference in voltage being able to be passed through this new even saltier water, showing that the voltage reader, whether there is 1 tablespoon or 5 tablespoons of salt dissolved in the water, is able to differentiate in voltage the difference between fresh, a little bit of salt water, and a lot of salt water. Thank you. I will now be testing how this highly concentrated salt water, room temperature, affects the output of the water depth sensor, as the water depth sensor uses voltage to determine the depth of the water. My hypothesis is that the depth sensor will be adversely affected and give an inaccurate reading, given that the voltage will be more easily passed through the salt water than the calibration of the fresh water. I will now test it. As you can see, the analog output reading is much higher than the previously tested fresh water. The correct depth is that of before, 24 millimeters, as I said, as accurately as a human could possibly measure. Wow. The depth sensor was off by a lot. It was off by more than 20 millimeters, give or take. This shows how the depth sensor is adversely affected when there is salt water in the mission site water. This means that a separate code will have to be implemented to take the correct calibrations with the depth sensor, as the volt reader will first have to determine if there is salt water or not, and then afterward the correct calibrations will have to be applied to the depth sensor. So something like this does not happen, and we will not be way off on our depth reading. After making corrections to the code, we will now test the new code with the depth sensor in this 24 millimeter pool of water, the same depth as before. As you can see, our depth sensor is now more accurately able to determine the depth of water. While the actual depth of the water was more closer to 24 millimeters, we are afforded a 4 millimeter plus or minus margin of error. So during our actual OSV testing, our depth sensor would have done its job correctly. While it could be a little bit more accurate, and given the human error in this, the actual depth of the water might as well have been a little closer to 28 than 24, showing that our depth sensor in this new salt water is able to still do its job with a large degree or high degree of accuracy.